All right, so we were talking about sets. So remember, a set is a collection that lets you store unique elements in the collection, right? So there's no duplicates in a set. And what that means is that no two elements are equal to one another. So in Java, you have a set if for any pair of elements x and y, x dot equals y is false, right? So no duplicated elements where the duplicates are determined using the equals method. When you make a set, you've got your choice of two. Well, you have your choice of several, but normally you use one of two. So your first choice is hash set, and that's because it's very fast. Right? Most of its fundamental operations have constant time complexity. Sometimes you want a sorted set, in which case you would choose something like a tree set. Its fundamental operations are fast, but not as fast as hash set. So they are logarithmic in complexity. There's a third kind. Sometimes you might want a linked hash set, which is very fast. Again, so O1 complexity, slightly slower than hash set because it needs to do some extra work in order to remember what order the elements were inserted into the set. So it's sort of like it's like a hash set, and it's sort of like a list because the linked hash set remembers what order you inserted elements into the set. So that's occasionally useful. Okay, now sets don't have they don't support indexing, which means you can't ask a set for element number I, for example. Right? There's actually, so if you have a hash set, there's no way to ask for any particular element. In fact, you can ask the set if it contains a particular element. But other than that, there's no way in which you can ask the set for a particular element. So when you're using a set, if you normally you have to loop. If you want to do something with the elements of the set, you end up looping over the elements of the set. That's not exactly true for tree sets or for the sorted sets, so I'll describe those a little bit later. If you want to loop over a set, then you can use a for each loop. Right? You can't use a regular accounting style loop like a for int I equals 0 and so on, because there's no indexing. But a for each loop works for sets. Right? So if you have a set of strings, you can write for each string s in t. Right? The notebooks also show you how to use an iterator. So you can make an object that knows how to iterate over the elements of a set. And so the notebooks show you how to do that. The syntax is a little bit different when you use an iterator. And but for now, we'll just use it for each loop. All right, so we'll just do it this way. So suppose you have a list and you want to find all the elements that occur one or more times, right? So in other words, I have a list. There could be duplicated elements in the list, and I want to remove those duplicated elements, right? This sometimes happens. For me, it sometimes happens when I'm dealing with the course administration. Sometimes you'll get a list of students, but there will be the student names or student numbers or things like that will be duplicated because of how the list was generated. And so you want to go through and filter out all of the duplicated elements. Right? And there's lots of applications where you might have a list of elements and you only want to know what are the unique elements in that collection. So if you're in that situation, then a set can help you out. So for example, if I have a list of account names called CS account, then I can find the unique account names just by making a set, right? So I'm going to make a hash set called unique accounts. And all you do is you take your list and you pass it into the constructor of the hash set. And the set, the constructor for the set will iterate over the elements of the list and try to add each element to the set. A set will not let you add duplicated elements, so that effectively gives you back the set of unique account names. Now, if you want to sort if you want a sorted set, then it's also easy. You just make a tree set instead. Pass in the list of account names, and then you end up with a sorted set of account names. And then finally, if you want if for some reason you want to maintain the order of the elements that are in the list, you can use a linked hash set. I'm just going to start up Eclipse quickly here. And then I have all of this as in Eclipse, so you can actually see the code examples. We can actually run the examples in the slides. So while we wait for that to start up, I'll keep going. Now that lets you find the unique elements. Now, what if you wanted to find the duplicated elements in the set? Sorry, I just need to set things up here. Okay, so if you want to find the unique elements in a set, sorry, if you want to find the duplicated elements in set, then the trick is to use two sets. So you start out, by making a set of the unique account names, and you make a set of the duplicated account names, right? And they're both empty at this point. Now you loop over your list of elements. Right, so I'm going to loop over my list of account names using a for each loop. Then what I'm going to do is I'm going to take each account name and I'm going to try to add it to the set of unique account names. Right, so here I've got unique account.add. And I'm going to try to add that account name to that set. So the way the add method works is if that element there is not in the set, then adds the element to the set and returns true. If that element is already in the set, then add does not add the element to the set and it returns false. So what I'm trying to do here is I'm trying to ask the set, is this account name already in the set of unique account names? If it is, right? So if it is, then I'm not going to add it to the unique account names. Instead, I'm going to add it to the duplicated account names. So that's how that works. Now, if a name happens to be duplicated many times, right, then you'll end up calling this method several times as well, right? But add won't re-add a duplicated account name to that set. So you end up with two sets, one of unique account names and one of the duplicated account names. All right, so let me just quickly comment out code so we don't have to see everything all at once. And then let me adjust the font size. Sorry. It's set to default text font, so okay, maybe I can just change that. No, that's better. All right, so there's my list of account names. I'm going to add a bunch of account names. Notice that two of them are duplicated. So the first one and the second last one and the second one and the last account name, they're the same. I'm going to print out that list so that you can see the account names. And then I'm going to make a hash set, a tree set, and a linked hash set using those account names. So when we run this, the output that we get is down here. So there's my list of names. Notice that you can just print out a list, right? So in Java, you can print out any object. Most of the usually you'll end up with something sensible, So in this case, I end up with the list showing us the elements of the list. You don't always end up with something sensible. Sometimes you'll see what looks like gibberish, but we'll explain that in a couple of days. So when you make a hash set with the elements in this list, right? So notice that there's only 4 names in the hash set, which is good. So the names are unique, but the order of the elements does not match the order of the elements from the original list, right? And so that's what you expect when you use a hash set. There's no guarantee on the ordering of the elements in the set. If you use a tree set, then the elements end up in sorted order. So in this case, because they're strings, they end up in sorted alphabetic order. And if you used a linked hash set, then they end up in the same order in which you inserted the elements. So in this case, it matches the order that the names are in the list. And so that's the difference between the 3 main types of sets. Okay. Now, to find duplicated account names, right, we're going to run that code that I just showed you a few minutes ago. Right, so make 2 sets. Try to add the account name to the set of unique accounts. If it doesn't work, then add the account name to the set of duplicated account names. Right, and this doesn't work because a set doesn't let you add duplicated elements to the set. And so if we run that, there are your duplicated account names, right? Which is correct, right? It's those 2 account names there. Again, we're using a hash set, so notice that the order of the elements here does not match the order of the elements there. Okay. So this is the picture of what's happening in that last example. There's my list of account names. And I'm now going to I'm going to iterate over these accounts, over these names, and I'm going to try to insert them into these 2 sets. Right. So we start out with the first name. It's not in this set, so we add it to the set. The second name is not in the unique account set, so we add it to the set. Same with the third and the fourth. Right. And now when we get to the 5th name in the list, right? So that name there, it's already in the set of unique accounts. So it doesn't get added here again. Instead, it goes into the duplicated account name. Right. And then finally, for the last name in the list, right, it already appears in the set of unique accounts. So it goes into the duplicated account set. Right. So that's a picture of what happens. That's a visualization of what happens in the previous example. Okay, so sets in Java actually model the mathematical definition of a set. So if you know about set union, set intersection, and set difference, then the set class, or sorry, the set classes all implement methods that let you perform union, intersection, and difference. So an example of using a union, imagine I have a set of students who completed the first assignment, and I have another set containing the students who completed the second assignment. Right, so I've got a set of students who completed assignment 1, set of students who completed assignment 2, and I want to know who completed either assignment. Right, and so that's a case where you would use the union. Right, I want all the students who completed assignment 1 and all the students who completed assignment 2. Right, and I don't want duplicates of those names. We have a question. Aren't sets supposed to be only able to contain one of a particular element? Yes. So they can only contain, that's exactly what a set is. So you cannot have duplicated elements, that's right. So where did we see a set that had duplicates in it? So in the previous example, right, I've got 3 sets. Right, these are 3 different sets. None of the sets contain duplicated elements. That's a list. Right, so a list is allowed to have duplicated elements. Yeah, so the list, that's right. Yeah. All right, what's going on here? Oh, here we go. Okay. So one way to do, so the way that the set classes give you the union method, sorry, the way that the set classes let you do or let you perform a union of two sets is with the add all method. Right now, add all is, you have to remember that add all does something very particular. So it computes the union, but it stores the union in the first set. Right? So S1 add all S2 transforms S1 into the union of S1 and S2. Right? So in other words, it does not give you back a new set that represents the union of the two sets. I'll show you in a minute how to do that. Right? But S1 add all S2, right, changes S1. It doesn't change S2, it changes S1. Right? So you have to keep that in mind because sometimes when you're performing a mathematical operation, a lot of the time you want the result to be a new object, right? So when you compute the union, sometimes you want the union to be a new set, right? And you don't want to modify the original two sets that you're taking the union of. So you have to keep that in mind when you use add all, right? So the way add all works is it just takes each element of S2 and tries to add it to the set S1. Anything that's in S2 that's not in S1 obviously gets added to S1. Right? Anything that's in S2 that's already in S1 does not get added to S1 because sets don't let you add duplicates. Right? And so if you think about that for a minute, you can convince yourself that produces the union of the two sets and stores the result in S1. So, oh wait, this is exactly showing you what happens here. Okay, so if you want a new set that represents the union, then the way you do that is you make a copy of one of the sets. So my set of students who completed either assignment 1 or assignment 2, right? It starts out as being equal to the set of the students who completed assignment 1. And then I simply add every student who completed assignment 2 to the new set, right? Or I try to add them. So picture what happens is as follows, right? So there's the students who completed assignment 1. Those are the students who completed assignment 2. There's my set of students who completed either assignment. So it's a copy of S1, right? And now I'm just going to loop over the elements of S2 and try to add them to S1 and try to add them to the set here, right? So when we loop over this set, right? Is this element in this set already? The answer is yes, so we don't add it. Is that element in this set? The answer is yes, so we don't add it. Is that element in the set? No, so we add it, right? And is that element in the set? So no, so now we add it as well. Right? So that's how you compute the union of two sets. You can run it. Eclipse. So here's my set of students who completed S1, right? There's my set of students that completed S2, and there's the set of students who completed either S1 or S2. And so when we run that, we should get the same output that's on the slide, right? And it looks like we do, right? So that's all of those students, right? Plus, oh, I didn't print them out. Plus these two students here, right? And now notice that the order of the elements, it's different than the order. So that was the original set, right? Notice that when we add these two students to the set, they get inserted in some they get inserted in some way that we can't tell, right? So QZ gets inserted at the end, and DebC gets inserted somewhere in the middle, right? And you can't actually predict where they're going to go into a hash set. So the set intersection, so that's the set of that's the set of elements that are in both sets. Right? They're in set 1 and in set 2. Right. So if you've seen a Venn diagram before, then the intersection is just the overlap of the two sets. So again, if I want to figure out, so I have two sets representing the students who completed assignment 1 and assignment 2. I want to know who completed both assignments, right? That's when you would use the intersection. Retain all is the method that computes the intersection. Like add all, retain all changes the first set. Retain all transforms S1 into the intersection of S1 and S2. And so the way this works is, for each element in S2, right, it checks if it's in S1, right? Elements in S1, then it keeps it in S1. If the element in S2 is not in S1, then it removes that element from S1. So that's how retain all works. If you don't want to transform the first set, so if you want a new set that represents the intersection, then you just make a copy of the first set and then call retain all. A picture of how this works, right? Students who completed assignment 1, students who completed assignment 2. The students who completed both assignments, we start out by making a copy of S1. And now we loop over this set here. So we're gonna look at this name here and check, is it in this set here? So the answer is yes, so we're gonna keep it. We'll look at the second name, right? The second name in this set, the answer is yes, so we'll keep it. Is this name in this set? The answer is no, right? So we're going to not include that in the final result. Is this name in this set? The answer is no, so we're not going to include that in the final set. Okay. And now notice that these two names, they're not in here, so they'll get removed from this set as well. We end up with the intersection of the two sets. There's the second example. And if you run the second example, you see that the answer matches what's on the lecture slides. Okay, last example is with the set difference. If I want to know the students who completed only assignment 1, that's when you use the difference. I think I misspoke a second ago. I think when I described retain all, I actually described remove all. So remove all is the one that loops over S2. No, that's not true. Sorry, that's fine. So remove all loops over S2 and checks if that element is in S1. If it's in S1, then it's removed from the result. So the remove all transforms S1 into the set difference of S1 and S2. Right, and again, if you don't want to modify S1, just make a copy of S1 and modify the copy. Remove all. Students who completed S1, students who completed assignment 1, students who completed assignment 2, start by copying the set of students who completed assignment 1, and now start removing elements from S2. So did this person complete assignment, only completed assignment 1, right? So is this person in this set? The answer is yes, so we're going to remove them. Right. This person in this set, the answer is yes, so we're going to remove them. This person in this set, the answer is no, right? So we don't remove them. Is this person in this set? The answer is no, and we don't remove them. So it's going to remove the first two elements and leave the last two elements. So that's all that I want to talk about for sets. Sets aren't, so sets don't have, oh wait, there's something else I want to talk about. I want to tell you about tree sets. So tree sets are a little bit different. Well, they're not different. They add extra features that you don't have in the other types of sets. So in 121, they would have taught you about sorting, right? And the reason we teach, one of the reasons we teach you about sorting is to teach you about algorithms, right? So we try to get you thinking about how do you translate a description of code, sorry, a description of an operation into actual code. So that's one of the reasons. The other reason is sorting turns out to be very useful. Solving a problem on a sorted collection is often much easier than sorting a problem on an unsorted collection. So that's true with sets as well, right? So sometimes so if you make a sorted set, there's a lot of things you can do with a sorted set that you can't do, or where it doesn't make sense to do the same thing with an unsorted set, right? So one of the things you can do, this is the tree set documentation. Tree set is what's called a sorted set. I'm going to describe these short. Hopefully, I'll get to the end of the map lecture today, so I'll describe these in more detail. But because the set's sorted, there are operations you can do with a tree set that you can't do with a regular set. Okay? So, for example, right, you can return the first element of a sorted set. Right now, that makes sense for a sorted set because there really is a first element, right? It's the elements are sorted, so you want the first element, right? It doesn't make sense for a hash set because the elements are in no particular order in a hash set, right? So it doesn't really make sense to get the first element out of a hash set. Similarly, you can get the last element out of a hash set. Out of a tree set, right? Again, because the set's sorted, so it makes sense that there is an element that is largest, right, in the set, right? That's the last element. But there's a lot of other things you can do as well. So, for example, there's a method called head set, right? And so the head set method gives you back all the elements that are less than that element there, right? And that makes sense for a tree set because it's sorted. Doesn't make sense for a hash set. Right? If you want all the elements that are bigger than a certain element, that's the tail set. Right? So tail set returns the elements that are greater than that element there, right? And then finally, there's a subset method. So the subset method lets you get a subset of the set, right? So I can get all the elements that are, how does this work now? That are equal to or greater than that element, but less than that element, right? So tree sets can do more, or sorted sets can do more than other types of sets, right? There's lots of other operations that they provide. And we're going to see exactly how the Java language introduces this extra functionality in the next, well, hopefully by the end of this lecture. Let's see if we get there. So the next lecture is on maps. Now, one of the reasons I had to tell you about sets is because maps use sets. What am I trying to do? Slideshow, current slide. Okay. So as Python programmers, you know what you know as a dictionary is what Java calls a map. And what Java calls a map, a person who studies data structures would probably call that an associative array, right? So these are all names for the same thing. So they're all names for what's called an abstract data type. So a data type, you know what a data type is? It's just a type, right? So in Java, that's just a class, right? Or any primitive type. When you get to, if you take CISC 235, the data structures course, they'll tell you something. They'll tell you about something called an abstract data type. So an abstract data type is a formal, which means mathematical, specification of a type. So you can describe what a list does using mathematical notation, right? You can describe what a set does using mathematical notation. You can describe what a map or dictionary does using mathematical notation. Okay. So those are all examples of abstract data types. Now, when you go to program, when you actually go to implement one of those data types, it turns out there's lots of different ways that you can do so. Right? So when you implement a set, right, you can choose to implement it as a hash set, or you can choose to implement it as a tree set. Right? And those two different types of sets, they have different characteristics. Right? They're both sets, but they have different advantages and disadvantages. Right? So sets and lists are actually abstract data types and their implementations in Java would be things like hash set, tree set, array list, or linked list. So the actual implementations have different properties. And you'll learn all about this sort of stuff in CISC 235. You learn a little bit more about this towards the end of CISC 124, where we actually implement an array list and a linked list. So the Java map implements similar functionality to a Python dictionary, but the syntax is very different here, right? So if you like using Python dictionaries, the syntax for using a Java map is quite different. Right? Now, Java gives you multiple different types of maps. Python also gives you multiple different types of maps, but you probably weren't told about them. So it turns out in Python, you can in fact get a sorted map, I believe. It's just that the maps you probably, the dictionaries you probably used, they probably didn't tell you that there were different types of dictionaries that you could choose from. So in Java, there's a hash map, which is similar to which is, I guess, analogous to a hash set, and there's a tree map, which is analogous to a tree set. Now, the hash map is the one that's most similar to a Python dictionary if you use Python, if the version of Python you're using is less than 3.7. So that's a type of dictionary where the key that you use to access an element, they're completely they are in some arbitrary order, right? So I'll explain that in a second. A tree map, that's a dictionary that keeps its keys sorted. If you're using a version of Python that's 3.7 or greater, and then it turns out that's actually closest to a linked hash map. A linked hash map, like a linked hash set, will remember what order you put things into the map. And so when you iterate over the elements, you get them back in the same order that you put them in, which is how the updated version of the Python dictionary works. Okay, so in a map or in a dictionary, you use what's called a key to access an element. Right? And so the keys have to be unique in a map or in a dictionary, which means the keys form a set. So in Java, that's explicit, right? So you can actually get the set of keys from a map. Every key maps to at most one value, but multiple keys can map to the same value. So the values that are stored in the map aren't necessarily a set. And the key value pairs, those are called entries, right? So if you think of a list, right, you know that a list has you can use an integer index to access an element. Right? So the indexes in a list, those are analogous to the keys in a map. Right? And so for a list, right, the indexes are unique, right? 0, 1, 2, 3, 4, 5, up to, but not including the size of the list. Right? The elements in the list, those are the values that are in a map. Right? So map is basically a 2-column table where the elements in the first column are unique. Right? So here's an example. Right? So here's an example of a map where my keys are the months of the year, and the values are the number of days in each month. Right? So they're all unique. Right? The values are not necessarily unique. And there's lots of examples of maps. So a mathematical function, assuming you've taken the calculus course already, then you should have been told that a function is also called a map, right? And so that's the Java map is actually a description of the map. It's actually a generalization of the mathematical function, right? So if you have a function of the form y equals f of x, then you know that the x values, those are unique. So those are our keys. You know that the y values are not necessarily unique, right? And those are our values, right? So so for a mathematical function, every value x maps to one value y. You have a written language dictionary or a spoken language dictionary, right? Then you have a set of words, right? Each word can have one or more definitions, right? So you can store a list of definitions in a map. The keys can be any type. The values can be any type, right? So I can actually store a list in a map. The number of days per month, right? So each month maps to a certain number of days, right? February maps to a possibility of 2 days. Each province has a capital city, right? You could invert this relationship. So you could say that every capital city maps to one province. The only problem with that is if one of your capital cities is also a city in a different province, which I don't think happens in Canada. I think the capital city names are unique in Canada. I'm not 100% sure though. But for sure, there's the province names are unique. So for sure, this relationship is correct. You have an index in a book, then the index has a bunch of keywords, right? All the keywords are unique, right? Each keyword may appear on one or more pages, right? And the pages are also unique, so you could store this as a set of pages. Student marks in a course, right? So when I go to submit your student marks, then they're done by student number, right? So each student number maps. So when if I have a big Excel spreadsheet, right? Each student number maps perhaps to a list of marks. So the mark for assignment 1, the mark for assignment 2, and so on and so forth. Alternatively, if you wanted to be a little fancier, right, I can map each student number to another map, right? And inside that map, right, I have your name and I have the name of the assignment, sorry, the name of the assignment or the whatever items contribute to your grade, right? And each one of those maps to an individual mark. So you can have a map whose values are other maps. So you can actually build very complicated. You can build very complicated. You can have very complicated representations of maps. So these values can be any type. The keys can also be any type, but it would be unusual to have a key that's another map. All right, so the difference between hash map, tree map, and linked hash map is primarily in the speed of their operations. Well, that's one of the big differences. So the operations for maps are called get, put, and contains key. So those are the three big operations, right? The three main operations. Get lets you get a value out of the map using a key. So that's similar to the get method for lists. Sorry. Put lets you put a key and a value into the map, right? So that would be similar to add for a list. Then contains key returns true if a key is in the map and false otherwise. So that's sort of similar to contains for a list. For hash map, these operations are all very fast in most cases, right? So unless you have an unusual collection of elements in the map or an unusual collection of keys, then for hash map, these operations are constant time, expected complexity. Right, so big O of 1 expected complexity. Tree map, these operations are also very fast, but they're not as fast as hash map, so those are O log n. Oh, Tree map keeps its keys in sorted order, which means the keys have to be sortable, right? So whatever type you use for the key, you have to be able to sort those keys. And so that means that the key type has to have a compare-to method. If it doesn't have a compare-to method, then you have to tell the map how it should compare keys. And the way you do that is you give it what's called a comparator object. And we'll talk about these in a week or so. Finally, there's linked hash map, which keeps the keys in the same order in which you insert them. Right? It's also very fast, so constant time complexity for the main operation. So how do you put entries into a map? You use the put method, right? So the name is intentionally different than for lists and sets, right? So for lists and sets, you would use add. For maps, you use put. Right? One of the reasons the name is different is because you have to pass two values into the put method. Right? You need to pass in the key, and you need to pass in the value associated with the key. Now, when you make a map, you have to tell the map what is the key type and what is the value type. So when we make a map, now there's two generic types. And so the way you specify them is by writing the type and then a comma and then the second type. On the right-hand side, you don't have to specify the types, right? Just use the empty diamond. The compiler will figure out that you mean a tree map of string and string. Right, so now there's two generic types that you have to specify. Oh, so this example here ends up building the map here. Right, we're making a tree map. Right, so the constructed map has the keys in alphabetic order. So Alberta at the beginning and Saskatchewan at the end. Everything else in sorted order here. To get a value from the map, the method has the same name as for lists and sets, right? You use the get method. When you get a value, instead of unlike a list where you pass in an integer index, right? With get, you pass in a key, right? So if I want to get the capital city for Ontario, right? I pass in the string Ontario for the get method. Right, and that should return the city Toronto. This is case so for maps, the key, this key has to be equal to some other key to some key that's already stored in the map. Right, so if you wrote little o Ontario here, get would return null, right, indicating that there is no value mapped to little o Ontario. Right, so you have to be careful when you use get with a map, because the value over here can be null. Sorry, the value returned by this method can be null. Right? Remember, null means no object in Java. So if you try to use the return type, if you try to use the variable city, and the value of city is null. So for example, if I try to get the length of the name, right? So I try to do city.length, then you'll end up with a null pointer exception. And that means that when you're using get, most of the time you have to check if the result is null or not, right? So if city equals null, don't do something with city, else go ahead and do something with city, right? So when you're using maps, often you have to check the return value from get. If you want to know if a map contains a key, then you use ContainsKey. You use the ContainsKey method. Right? So if I want to put in the territories and their capital cities into this map, right, then I can check, right, does the map contain the key Nunavut? Right? If it does, we'll do nothing, right? Because I have the negation operator here, right? So if Nunavut is not in the map, I'm going to put Nunavut into the map with the capital city Iqaluit. Northwest Territories is not in the map. Then I'll put in Northwest Territories with the capital city Yellowknife, and the same for the Yukon. So that's ContainsKey. One of the common uses of a map is to count the number of times each thing in a collection appears. Right? So if I have a list of strings and I want to know how many times each string appears, you can use a map to do this. Now, the reason you might want to do this is you might want to know what is the most commonly occurring string, right? And how often does it appear? You might want to know what is the least occurring string and how often it would appear. Right? Another example, another common introductory programming course example of this is when you a lot of introductory courses, they have you they use poker as an example of a programming problem, right? So for a poker hand, there's different types of poker hands, and you need to figure out. So if you're given 5 cards, you have to figure out what poker hand do the 5 cards represent. Okay. You can use a map to help you solve this problem, right? So count the number of times each card appears in the hand, right? So if a card appears twice, you know that you might have a pair, right? If a card appears 3 times, you might know that you have 3 of a kind, right? And so on and so on and so forth, right? So it turns out using a map is very useful in solving the poker problem. It's much harder to do if you don't use a map. Right. Okay, so to solve this particular problem, right, counting the number of times each string appears in the list, then what you do is you make a map. Right. Your keys are the unique strings in the list. Right. Now you don't have to worry about what are the unique strings because you can let the map figure that out. And the values are the number of times each string appears in the list. So it's pretty simple to do. Right. I make a map. Right. Key are the strings that are in the list. Right. The values are the number of times each string appears. Okay. So remember, T is a list of strings, so I'm going to loop over my list of strings. String S in the list T. I'm going to ask the map, right, do you contain this string? Right. So if you don't contain the string, we end up down here. Right. So when you come to a string that's not already in the map, right, you know that's the first time you've seen that string. Right. So in other words, you know that that string has appeared once so far, right? So you put the string into the map with a count of 1, right? Now, if this returns true, then you know that you've seen the string S before. So what you want to do is you want to update the count of the number of times that string has appeared. What you do is you get the number of times that string has appeared from the map, right? I don't have to check the return. I don't have to check if the return value here is null because I know the key is there, right? So I can safely use n here without worrying if it's null. And then, so that's the number of times I've seen S so far, right? I've seen it 1 more time, right? So I put n plus 1 back into the map with that key, right? And that lets you count the number of times each string appears in the map. Can you index the map? No. There's no indexing, right? So in Python, you would use square brackets, right? In Java, you cannot. The only thing you can use square brackets for in Java is with an array. So there's no operator, and it's because Java doesn't have operator overloading. All right, so that's 19 after the hour, so I should stop there. Does anybody have any questions about sets or maps? All right, so I'm not seeing anything. Does anybody have any questions about anything else? I guess maybe related to the assignment. Assignment 2 will come out later today or maybe tomorrow, but I think it'll be done today. Assignment 2 is basically using strings, lists, and sets to solve a current problem. I'm wondering what's the difference between something like int and list. Oh, so one's an array and one's a list, right? You can do a lot more things with a list than you can do with an array, right? So with an array, if you want to do something like add an element to the array, right, then you have to do all that work. Like if you want to insert an element into the middle of the array, right, you have to do all of that work by yourself. Right, so you have to shuffle a bunch of elements down the array and then insert the element into the freed location. Right, with a list, you just use add. There you go. Okay, so lists provide lots and lots of methods that you would want to be able to use with an array, but you don't have them, so you have to do it yourself, right? If you want to use an array. Now, the trade-off is that list adds there's some overhead with using a list compared to using an array. Right? So getting an element out of a list is slightly slower than getting an element out of an array. Setting an element in a list is slightly slower than setting an element in. Not related to the assignment, but how's your day going? Oh, thanks, Christian. So far, so good. I like the 10:30 start much more than the 8:30 start. So far, so good. All right. I guess that's it. Agreed. Yeah. So it's going to be interesting when we go back in person after reading week. Last term, yeah, 8:30 can die. I agree. So last term, I did have 124 at 8:30 one day, and I basically got like 5 students showing up for that lecture. Everybody else would just stay at home and watch the live stream or watch the recorded version. We have a question. I have a question about lab 2. Are we supposed to find a way to figure out how to swap the points, like by creating? No. So when you swap, so the whole point of the swapping exercise is that you can't swap 2 points, right? So I can't take a point A and B and then write a regular swap for A and B, right? So what you have to do is you have to switch out their coordinates. Right, so I'm going to take point A and I'm going to change its coordinates so that they're equal to the coordinates of point B. And you're going to take point B and you're going to change its coordinates so that they're equal to the coordinates of the old point A. Right, but you can't actually swap the variables. Right? So just switch their coordinates. Right, so you're allowed to do that. So you can change the state of an object using a method in Java. What you can't do is you cannot swap 2 variables using a method in Java. Does that answer your question? Oh, okay. Is it okay that it doesn't swap in the end by the method? I'm not sure what you mean by that. Is it okay that it doesn't swap in the end by? I'm not sure what your question is asking. Let me pull up Eclipse and show you. Here. So when you swap the coordinates, right? So basically here I want to swap coordinates P and Q, right? And so to set a coordinate on P and Q, you can either use the set method or you can use the X and Y methods, right? Like I showed you, I guess last week or 2 weeks ago. And so all you have to do here is you have to remember what are the coordinates of one of the 2 points first, so that I can safely switch out the coordinates, right? So I can do something like double px equals px, like that, right? And then double py equals py, like that, right? So I remembered what the old coordinates of p are, right? Which means I can go ahead now and change the current coordinates of p, right? So I can do p set q x y, like that. And now I can go ahead and change q's coordinates. So q set the old px and the old py, and that's it. You're done. Right. So you can do something like this in Java. I can change the state of an object, right, by using a method. But what I can't do is I can't make p point to whatever q is pointing to, and I can't make q point to whatever p is pointing to. That doesn't work. Right, that's the whole point of this lab. Well, that's one of the main points of this lab. Right. So hopefully that answers your question. Right. So when I call the method from where? Do I ask you to call it? Oh, I don't actually. If you called it from the main method, the coordinates would actually swap. Yeah, you're welcome. Any other questions? Okay, super. So I will see you next week. Everybody have a good weekend. Try to take some time off. And yeah,